We're going to look at factoring trinomials that have a lead coefficient of 1. You can write trinomials very generically as ax squared plus bx plus c, where a is the coefficient of the first term, usually the term with the highest exponent. So in our example here, our a term would be a 1. B is the coefficient of the middle term, which is usually the x term, and in this case that's a 9. And finally, C is the number that's by itself without the variable, and in this case that's 18. So we're going to go ahead and factor this, and the method I'm going to show you only works when your leading coefficient is a 1. So what I'm going to do over here on the side is I'm going to draw two little trees. The first one is going to have the C term, that number by itself at the top, and the second tree is going to have that middle term at the top. And what I'm looking for is a pair of numbers. So I want a pair of numbers, and it's going to be the same pair in both cases. So two numbers that will multiply together to make 18, and those same two numbers will add up to 9. So think about what numbers you can multiply together that will make 18. So for example, 2 times 9 equals 18. But then when we go to add up the 2 and the 9, we get 11. And that's not what we want. We're looking for a 9. Another combination we might try is 3 times 6. Well, 3 times 6 is equal to 18. And 3 plus 6 does add up to 9. So those are the two numbers that we want, a 3 and a 6. And they work in both of our little trees there. So now we're pretty close to our answer. All we have to do is actually write the answer formally. So let's go ahead and do that. Our answer is going to be the product of two binomials, and the first term is always going to be x. And then the second term you're going to take from the numbers that we just found, that pair of numbers 3 and 6, we have a positive 3 and a positive 6. And that's it. You factored. So to check, we'd want to check our work by foiling out what we just got. So if you FOIL out x plus 3 times x plus 6, you should get the original problem, which is x squared plus 9x plus 18. All right, let's try another example. Let's try this one, x squared minus 9x plus 18. So I've left the numbers the same, but I've changed a sign there. So that's going to change a little bit what we're looking for here. So let's draw our two trees. And so we are still looking for an 18. That's our C term. So we are looking for two numbers that will multiply together to get 18. And we are looking for two numbers that will add together to get that middle term, that B term, of a negative 9. So now when we're looking, we have to somehow figure out how do we get two numbers which will multiply together to get a positive 18 and will add together to get a negative number. Well, when we're adding things together, if we add two negatives, we'll certainly get a negative number. And if we multiply two negatives together, we'll get a positive number. So that looks like that's going to be our strategy. In order to get a positive 18, we have to multiply two negative numbers together. So what if we multiplied a negative 3 times a negative 6? Well, that will give us a positive 18. And what if we add a negative 3 to a negative 6? That will give us our negative 9. So we've got the two numbers that we need, negative 3 and negative 6. So let's write that in our answer here. We have two binomials. We know that's our answer is going to look with two binomials. And the two numbers that we just got are negative 3 and negative 6. And again, if you check that by foiling, and go ahead and try checking that just to make sure. So check that answer by foiling. When you FOIL out x minus 3 times x minus 6, you should get back to our original problem of x squared minus 9x plus 18. Now just remember, when you're using this technique, it only works when your leading coefficient is a 1. If the leading coefficient is not a 1, then we've got a different technique that we're going to use.